Thank you all for hanging out for the second half of the CI/CD meetup talks this evening. The presentation that I have prepared, I'd actually, just to give some context, I'd initially put it together for more like kind of streamlined, bam, 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 to the minute talk down in Belgium for DevOps. It was for more of a generalized crowd, and now I'm in front of esteemed colleagues with considerable CI/CD experience. So some of these things I may pull an audible on and dive into maybe more interesting things, but we'll kind of use this as a guide for now. So cool, let's dive into it. The obligatory introductory slide. My name is Tom Stoker. I'm currently a software engineer at bull.com. I've been now with the company for a little over a year. Yeah, it's been a really cool journey. I came onto the company now in this really interesting time period where, speaking of cloud, Netflix, hold on. All right, thank you, Netflix. For many things, not just a really great mobile app, but also some really cool tech. But anyway, we'll get into that later. So my name's Tom, software engineer at bull.com. Bull is under this really cool transition period to cloud, specifically the Google Cloud. And I came on bull.com with some experience in cloud, actually exclusively Amazon before working with Bull. So this is my first dive into to the Google stuff. And we'll get into that a little bit more. I'm at the usual haunts on the internet: GitHub, Stack Overflow, and a Hugo static site on a Heroku free tier, which probably will take 30 seconds to load it the first time. So should probably just move that to a static site on Amazon, but priorities. Netflix for my 2-year-old, 3-year-old. Cool, so let's get started with this presentation, but of course a disclaimer of any presentation with buzzwords. Well, maybe some people don't give disclaimers for buzzwords, but I like to, because. So let's just start rattling them off. Agile, Scrum, DevOps, fail fast, iterate. Unto themselves, actually, I think are really compelling ways of working. But at scale, whether that scale be your startup being maybe me and now I have a partner, or your company being bull.com going from 1,000 employees to 2,000 employees, things can get weird. And so these words, these ways of working, there's these like slight transformations. This is what I mean by things get weird. So agile can quickly become fragile. Scrum can often disintegrate just into crumbs. So just shuffle the ass out of B. DevOps, dev flops, and iterate can turn into obliterated in quick succession.
Myself because it's really stuck.
Speaking of, okay, one sec. Let's just go no headphones.
No headphones.
Yeah, let's just get rid of
Headphones don't stop.
no middleman to the audio. Let's just go straight raw. Cool. So yes, these are really interesting ways of working, and I think unto themselves have some really compelling characteristics. But I think maybe this was not like part of the routine or anything. Oh, you can't hear it. So volume. Yeah, this should be in the book. Well, the book is too low level, so we're just gonna be a consumer computer user, and we're just gonna press the volume button. There you go. Sweet. Awesome. All right, we'll see what happens here. But yes, the challenges. I mean, unexpected events occur. There you go. That's chaos, right? Chaos monkey, like happening in real life. If you're familiar with that framework from Netflix. So these ways of working are really interesting, and I think they have really compelling characteristics about them. But within organizations, within demands, within feature requirements, within whatever happens in the real world, I think them unto themselves. Oh yeah, of course I went last one. Fail fast. Often just degrades to failure, which is, okay. Cool, so then all of this, so then what? And when I ask myself, then what, I turn to Twitter. Well, not really, but yes, actually. And this tweet here I found has had some shelf life to it. This was from the imitable JBD. She works, as far as I think, if I follow her correctly on the internet, at Google right now, on the Google Cloud platform. And she had an interesting tweet out there: don't blindly apply dogmatic advice, use your judgment every time. And it was funny, I read that and I was like, okay, cool, I understand what that means, but then I was like, actually I don't really know what dogmatic means. So, the first thing that popped up was inclined to lay down principles that are undeniably true. And I think with some of these ways of working, you get like Scrum, and this is how it happens, and this is how it happens. And I think there is some truth, but it's not universally true. So back to what she mentioned here, I think using the experience you have as engineers, as business people, as artists, as whatever your backgrounds and interests are, apply that information to information being presented, I think is just good advice. So for me, I hear all of these things, and then of course being the engineer who just like wants to deliver like reliable code that's useful, it's like, okay, let's maybe shift our focus to maybe something more tangible, like an objective. And so for me, it's like about writing software that users can trust, and that also performs in a way that I can get some sleep in. So I can handle Netflix problems. Love you too, girly. Cool. So that being said, can Agile enable this for a team? Can DevOps enable for a team?
He's silly.
What? Okay, hold on. Okay, we have to have a quick family discussion. 30 seconds. One.
Is this scripted?
All right, we'll see how long that pep talk keeps her entertained. Thank you for providing the beanbags. It's like such a cool resource, actually. So plus 2 on that one. But yeah, can Scrum enable this for this team? Can failing fast? And then of course, the question, the answer then is often maybe. And then for me, for the teams I've been working with at Bowl.com, perhaps we need to just think about things a little bit differently than just these like dogmatic ways of working. And maybe look at even a maybe way more grand existential concept, but thinking just about the software we're developing for now. What are we building? Is it sustainable? And so shout out to Uncle Bob. Let's get actually started. So what are we talking about here? What I'm proposing is this notion of sustainable innovation, and I don't think it's necessarily innovative unto itself, but I think it is something that is often lost in the hype or the flow of delivering features and trying to make sure they're secure retroactively and stuff like that. An approach to sustainable innovation using my experience at Bowl.com and what Bowl.com has done historically before my time there, speaking with colleagues with that information. And then team autonomy in practice. So we'll get into what an approach to sustainable innovation being team autonomy. We'll tie that all together in a moment. So back to this definition, or maybe the first time I throw this up here. But my kind of concept, the way to unpack this into more words, but creating or improving a core value proposition without regression in a way that is maintainable, but in the context of dynamic and ever-changing business requirements. And it is interesting because being a software engineer, especially under, I think the further I've gotten into this career, the more the business world that I'm trying to write systems for becomes very dynamic and becomes, users want this one day and then they want this the next, or maybe politics determines that this is the feature we need to ship or whatever. And I think as an engineer, you kind of have to try to just try to get a good foothold, and that's where I think that this concept of CI/CD, and it's really cool to hear more and more people really talking about it, because you need things that can just keep the ship stable while all this stuff is kind of turning above it. So the questions that I ask myself, or that I've been asking with my colleagues lately, as we're looking at embracing change and how do we do this stuff sustainably, is there any risk in developing a feature? And then the next question is, once it's shipped, how will it be maintained? This is a question that I've at least found in my career that's not asked enough. It's like, great, we're just going to ship. And then it's like, whoa, 42 serverless functions, man. Holy cow. I mean, I've seen some DDoS, man, and some serverless, dude. It's self-inflicted, you know what I mean? Distributed somehow. Crazy. Anyway, is the value proposition of the feature line or business model? So getting back to our business hat, like, it's really cool to build a whiz-bang, but like, does my customer really just need to fill out a form in like under 1 second because they have to get back to taking care of Netflix for their kid, So really, what is the value proposition of what we're working on? And then does the value proposition of an engineering decision improve how the product is used as well? So oftentimes it's really cool to get into tech, but is it really improving the product that I'm working on? And that leads to the next slide here. Technology is not, in my opinion, technology is not often innovative unto itself, but a potent enabler for something truly innovative. And that there's obviously, like Kubernetes to me is like totally insanely innovative. So I'm not like, saying these things aren't, but ultimately like Kubernetes exists because people want to search for stuff. And that's, that's a whole other rant unto itself. So that being said, chasing the hype as an engineer, going back to this point, there's all this cool tech and all of this, everything on here plus more is like super interesting stuff to deal with. And as an engineer, it's really compelling to chase after this stuff. But does it really compel? Does it really push my business? Does it really help the platform I'm working on, the systems I'm working on, be sustainable? That said, hype is really cool, but it's not always great for business. But it is always good for GitHub stars and Stack Overflow points, which is cool. And also just growing as an engineer, so pardon the sarcasm, but also looking at different ways larger organizations or smaller organizations like the Toolbox, part of the CLA, how are organizations dealing with these problems? So these tools quickly become hype once they become useful, and then ideally become exactly. So then, thus getting back to sustainable innovation, are we just chasing stuff as engineers? Are we, as business people, actually building something that can be maintained? And I think oftentimes in business you forget that after it ships, it does need to be maintained. So this is like a very epic problem, and I think it's a problem that we face with small teams, with large teams. So how can this actually scale? And so that brings me now. Let's try to make this a little bit less me going on some kind of existential side rants, but let's look at a real company, and Bowl.com I think is a very, very compelling company to look at around these concepts. I imagine most people in the room know who Bowl.com is, but the obligatory bio here, and in all respect, when I say that, launching in 1999 with 26 employees. From what I understand, it was the first online bookstore in the Netherlands, and that's pretty cool. Considering that, if you think about that, was the first .com bubble burst, so it's pretty amazing. The company in the Netherlands was able to launch in '99, and now in 2019 have over 1,800 employees, offering 21 million products, and is the largest retailer in the Benelux region. It's a pretty cool evolution if you think about where it got its start. A nice little chart that some of my business colleagues could probably explain better than I could, but all the cool stuff that's happened over the years. And then from a technology perspective, Bowl.com has remained agile in the sense of where early on things were actually all of Bowl.com was one big monolithic application, and it was actually deployed from what I hear from my colleagues by a third-party provider. And then since they've evolved into a DevOps-driven, service-oriented architecture, where they have been running their own data centers for some years now, and now moving into this hybrid and more chips on the cloud. So pretty compelling that a company of this size over these years, considering competition, has always tried to maintain an edge in terms of being able to be competitive from a technology perspective. And so in this sense, you can say, and if you look at their revenue numbers, it's interesting to see the sustainable growth that they've been able to maintain. So what has been the strategy for success? And a company like Bowl.com that actually started before Facebook and Twitter even be able to grow and scale and be as relevant as it is, especially in Western Europe. And that ingredient, and I see it now working there for a year, and it's something that is spoken a lot about by even the executives, is team autonomy. And how team autonomy flushes out at Bowl.com, really ways of working, roadmaps, even organizational structure at the micro scale, technology decisions, in certain cases even onboarding new team members, and then definitely product implementation details are all really determined at the team level, which is very interesting. And my initial approach kind of coming actually from some large companies in the US with more waterfallish type models. It's like, whoa, this is totally wild. So how does this impact sustainable innovation? And from my experience working in the industry, the success of a technology company is built upon thousands of these micro decisions daily. Developers are literally writing these epic novels that compile and run on machines, and are all collaborating all the time on this stuff. And there's tons of micro decisions that are made, and managing, especially at a scale of Bowl.com, managing something like this is really, really tough. And even if it is possible, could stifle ingenuity or stifle a certain level of creativity that could manifest in some very interesting competitive gains. So if we look at this as kind of my attempt at illustrating the two different models. One is kind of a company without team autonomy, and you have this dependency graph where you have C-suite at the top, and you have all the lowly engineers down here, staring at the glare of their computers, waiting for middle management to make a decision, and everyone's just kind of waiting, and there's this kind of blocking thing, and then it's the dependency graph is always up, and the decisions always kind of have to trickle back down, and it's not always clear why they're being made. In a dependency graph influenced by team autonomy, this actually kind of maybe looks more complex, but at the micro level starts to become much more interesting. So this team here maybe is responsible for media, and this team here is maybe responsible for some component of search, and this team here is maybe responsible for logistics. And of course we still have our C-suite. And but what ends up happening now is teams have these natural dependencies. I work on something, and now I get this cool initiative from C-suite to make more of the BAS-buzzes out there, and I need to make more BAS-buzzes by working with this other team. So instead of having this oh yes, we need approval from the server administration team to think about security, blah blah blah. It's like, cool, I work on media, you work on search. Let's build this thing, and the dependency graph can kind of more naturally occur. The secret to that, now that all sounds kind of chaotic, and it could be, and I think in some cases in real life it ends up being chaotic. But one of the secret ingredients that Bowl.com has, and I think any company that kind of pulls off the autonomous team structure, is really this notion of a common culture and goal. So not only are teams able to then form natural dependencies around what they need to work on, but there is a common thread. So it isn't just like me over here fighting the Amazon serverless SDK and trying to get Amazon on the phone. It's literally because I'm just working on something else. It's like, oh cool, we actually are all working on the same thing. And not to say that experience isn't awesome. It's just saying to do it at a large scale at Bowl.com, you really have to have a common understanding, or otherwise when the eventual bumps in the road hit, human friction comes into play in these things. So having a common understanding helps thread the autonomous dependency model. And that being said, that culture at Bowl.com right now is it's kind of old school. It's just the customer is first. But it's kind of like a weird thing I think I've found in working with some startups and with some really, really brilliant people who are just focused on something, but not necessarily focused on their end consumer. And it's really cool that Bowl.com stays very dedicated to their end customers, as well as the growing now partner platform to get more people online to help proliferate product and market choices in the Benelux region. So yeah, this kind of all sounds good in theory. And if it does, then maybe I sold it pretty good. No, but it actually I think manifests itself in a really interesting way. But that all said, okay, these are really interesting concepts. Okay, cool, we all work together, we're autonomous. But ultimately, we still need to write code, and we still need to ship software. So that can be very challenging. Okay, cool. I work on pictures, and you work on the picture, Snapchat filter thing. So obviously, we have to partner. But if we can't actually deliver code in a sustainable way, then what are we? We're just talking. So let's dive into even a more micro case study there. The team I'm currently the informal tech lead of, I guess, but working with Team Mirage, and what we work on is actually all of the media processing systems, everything from intake to serving to the web shop. And who is that?
Mommy.
Her ride is on the way. Hold on 1 second. Last interruption.
Let's go over and over and over and over.
Okay, all right. We'll speed it up for everyone's sake. Okay. Here we go. All right. So I'll kick it up into high gear then. That being said, we work on all the data. It's pretty fun. We get to process a lot of data, and then our web shop and our apps call us at a pretty nice rate. We're actually on Black Friday. It was fun. We hit 40,000 requests a second. We have Varnish and other caching systems in front, but we were kind of hitting, we weren't drifting above 20 millisecond response times, the 95th percentile. So that was kind of cool. So we get to deal with a lot of data and then get to serve it really fast. So from an engineering perspective, that's kind of fun stuff to work on. Due to the amount of stuff that's happening and a lot of the lack of transparency in prior years to our partners as they're trying to get content onto the website, we've now have an event system that's being aggregated for feedback, so people can actually trace things. And we're a small team. Actually, this is now 5 engineers as of 2 weeks ago, but it's cool that we're able to do a lot with a small team. And so the question is then, how can we enable a small team to sustainably innovate? So we have these huge requirements, we have all these other teams working on the products, we need to collaborate in kind of this organic way, but again, we still need to write software. And I am actually going on vacation next week, which is like, whoa, because it's been a lot of work lately. That being said, the goal in Team Mirage at least, and again, being the fact that we have the autonomy to kind of make our design decisions around how we operate, is effectively something like this. So reduce the cognitive load and time commitment to maintaining and provisioning and running software, and focus on enabling and writing it. And that's definitely not to mitigate the insane and severe importance of these three in bold words there, but the goal is that these things, and as discussed earlier, these things become a part of the fabric of what you're doing, and it allows other developers to then focus on business requirements and not necessarily about encrypted secrets. Those things aren't great for launching products, pretty critical for not leaking customer information or getting hacked or whatever else horrible things can happen when secrets get out in the world. So the answer is, of course, automate all the things, and that's a random jump. But, yeah, sorry about the sarcasm there. But in all reality, that is a meme that shows up all the time, and there is some weird truth to it, so I put it up there. So continuous integration and delivery, and that's kind of the cornerstone of how we're able to remain productive. And we're using GitLab at Bull.com. I really like GitLab. There's tons of awesome solutions out there. The nice thing for me with GitLab is you kind of have this simple model. I got Git and my code is here. I have these things that are aptly named runners, and they enable to me to kind of configure effectively whatever I want to be able to test, ship, and run my code. So let's talk about this. I did have some demos planned. I have GitLab running in Docker over here with runners, and I was about to set up a project and then hack through a bunch of setting up pipelines, but I think that might be a little boring because I don't have the time to really illustrate something super complex. So I might just dive into some other more interesting concepts we're doing with CI/CD, unless you guys like watching someone chip away at YAML files. But okay, no chipping away at YAML files. But we'll kind of highlight these factors. So testing, it's like kind of an obvious one, but how does this impact the notion of sustainable innovation? It allows us to improve the product with confidence and reduces possible regression. So we don't ship code unless our pipelines are green. Tests, obviously there's the implicit understanding that your tests are written well and that there's coverage. But given that, focusing on that we have a safeguard, which then also only allows us to onboard new engineers. So as a new engineer, I don't have to hop in and I'm like, is this house of cards? Like if I add something here, will like the whole thing tumble down over here? Yeah. So this being able to automate and test with confidence and make sure, for us it's automate. Similar model, we're doing Git Flow, so we got develop, we have feature branches, but like every push is and actually I think I saw a blog from you about just add code formatting, man. So yeah, and I was like, dude, you're so right, dude. So we do have, in Team Mirage, we're 100% Go, so we write everything in Go. So what's nice about Go is you have Go funked, so everything is kind of implicitly formatted. But we run formatters, Go vets. Now I guess you have to listen to me. Netflix, the battery has ran out. Well, do you mind taking the seat early? I'm almost done.
No.
No? Okay, think about it. All right, cool. Yeah, exactly. So these things I think are quite obvious, but I can't undervalue the importance of them. And then the setup that I had illustrated, there were other things. Ensuring I had a code formatter. The setup I was about to do only ran tests in GoVet. It didn't actually run GoFund to check in any updates, but quite critical. Like, let's not think about formatting. Let's just ensure that even if you check in sloppy code, we have Pretty or GoFund or whatever you're using format that stuff. And then additional static analysis checking, like SonarQube or whatever. GoVet is pretty cool in the Go world. It's kind of maybe all you need, but there are a lot of other things you can use. So building, and this is part for us is quite important. So obviously you want to be able to build your binary. You want to make sure that this thing actually compiles and just do it regularly. But for me, one thing that is so often lost in software development is versioning, man. And this part I maybe will demo quickly, but semantic versioning. So in Team Mirage, and maybe I have not on VPN, but semantic versioning. It's such a clear, simple, super important way to version software, and especially in the Go world, you see, now with Go modules and everybody talking about it, use semantic versioning. So we version everything semantically, and we use conventional commits. So for those who maybe are asking, well, why is this important? well, I don't know if you've ever been in the situation where you're like, wait, what are we working on? Oh yeah, version FF9387123, 9231.12. Cool, we're on that version. Oh wait, is it actually backwards compatible with this version? And like these are questions that just waste so much time and also introduce problems. So semantic versioning kind of helps just ice that problem altogether. And the quick overview for, and I'm sure everyone's familiar with it here, but in case we're not, or for me who needs to remind myself frequently, major, minor, and patch versions is effectively what these numeric, these numbers represent for us. Patches get incremented when you're rolling out small fixes that are backwards compatible. Minor is maybe when you're rolling out features or something notable. That's backwards compatible. That's the important part there. And then of course major, the minute you make a break and change to your public API, just bump it. Conventional commits, what are these? This is basically a standard on how you write commit messages. And oftentimes, so some examples you get here is effectively you see feat, it's a common prefix for feature. You'll see sometimes, and it looks almost like a function signature here, like almost Kotlin-ish with a return, but not really anyway. It's just a commit message. Feat with maybe the scope. Maybe I'm working on like the language settings in my application, and in this case I'm adding Polish language. And if I'm going to introduce a breaking change, I just introduce it loud and proud in the footer. So oftentimes when developers like who maybe haven't been around semantic versioning or conventional commits, I have oftentimes got this like, what, are you serious? Now we have to think about commit messages, man, you're such a commit Nazi, like whatever, man. But the cool thing is, again, back to the automate all things, using conventional commits allow you to just automate meaningful versions. And so if everyone's using conventional commits, you can use tooling that can derive the next versions for you. And so we built a tool, just a quick illustrate how this works. It's quite simple. Let's just quickly spin up a new code project. My proj, sure, code. And effectively, I have this tool versioner installed. Let's just go mod init my proj, have something cool, and we'll add a file. Good old main.go. Is this probably too small? Yes, it is. Cool. That maybe a little bit better. There we go, maybe. Cool. So anyway, we're just going to look at Git for a second. Super exciting, but kind of compelling. Touch main.go, sweet. So what am I going to do? I'm just going to add a commit message. So we'll git add everything here. Oops, I didn't get init. I'm just usually cloning from GitLab, so Git is always magically available. Cool. So we'll git add this. And then we'll commit this, but we'll use conventional commits. So I'll just say this is a task, project, setup. And so what will happen now, if I look at my Git log, obviously it won't be too fancy yet, but we have one. But if I run this tool versioner, what it will do is you can see now, it's already seen that I'm on my first patch release. So if I add some more, of course I don't have a readme yet, foolish me. So we'll add a readme. And then we'll just add it, and then git commit this one. This rainbow keyboard spacebar is really sticky. Sorry, guys. That's why I'm canceling the demo.
Daddy, don't talk.
What? Would you like to hear this for me?
No.
Okay, then I'll continue. Almost done.
Nope.
Almost done.
No.
So then, real quick,
No,
task,
no, no.
add readme. I know, you watch me do this all the time, I know, super exciting. Cool, so we run versioner again. As you can see, as you might expect, we're at 002, and now if I add, let's add a git ignore, probably should have one of those. Oops, let's actually add it. Cool, and then because the git ignore is so important, we'll add it as a feature. Feat, add git ignore, no spacebar, problems. And then, oops, I guess sorry guys.
Daddy,
What's up, you really?
you cannot talk every day.
Cool. And then run versioner, as you can see.
Stop.
Sweet. Almost done, I promise.
Nope.
Can you write the letter O, letter T, and letter N on the board, whiteboard? Red and black twice. Cool. So.
I cannot find black.
Okay. So as you can see, bump them up, you kind of get to see where this is going. But what's really nice is now, and we rebase and squash everything, so we have this really flat Git history, and it's super cool because now we're not fighting over, is this really a feature release, guys? It's like standard commit messages. We run commit validation, so no one's introducing crap into our Git history, and then effectively we just let our pipeline have versioner and spit it out. There are other tools out there. This is actually one I wrote because the best ones out there that I found are in Node, and then it was like, I just want a small binary that I can just run anywhere, and so I just wrote it in Go and just said done with it and compiled it in all target architectures, and you have it now. Cool. So versioning, super important.
Now you're done.
Almost, we're really almost done. So I'll kind of blaze through these. I'm talking to a room full of like people who fundamentally understand all these principles. So Git Flow, oh my God, let's not talk about Git Flow. Everyone knows about Git Flow, and if you don't, you already know about it anyway. Cool. So what does this all mean? So going back to this principle that I was kind of highlighting earlier before some interruptions and other things, as a developer, what are we doing? We want to reduce the cognitive load on maintaining our software and focus on writing it. So the goal at Team Mirage is now we have versioning, testing, configuring releases, building, and deployments all just summed up in just writing and committing code. So now we still use infrastructure as code principles where we actually, Bowl.com has rolled out a very compelling, still internal CI/CD release management tool that wraps actually Terraform similar, but it's using YAML and we're deploying Kubernetes, so it's calling kubectl under the hood, provisioning, Cloud SQL, whatever. But ultimately, still infrastructure as code. Developers write code, they commit code, and then CI/CD magically makes them look like heroes.
Now you need to stop.
Cool. So the last blazing.
Stop.
Seriously, almost done, sweetie. I
But
promise.
I want to go home with my mommy.
I know, me too. Almost. We're almost done.
But I hear that sound in there.
Oh, you hear a sound? Well, come over here. Just come over here. Okay, come over here. Just come over here.
Nope.
Come over here. I'll stand right there. All right. So, considering the circumstances, ladies and gentlemen, I do apologize. But what we will do is get through the last parts of
There is
this
a green
presentation.
marker. She can draw something
yeah.
for us.
Yeah. Here, maybe you can illustrate knowledge.
Yeah. Paint your favorite picture.
Okay, won't put it on the spot. So all of that being said, we're now, our application architecture, due to kind of high availability reasons, we actually did start introducing some Google Cloud functions, so we actually started dabbling in some serverless, but we're still pretty much like Kubernetes, and we're using Go and we're using Google, so we were talking earlier, our team is basically drinking Google Kool-Aid all day. Like, it's pretty awesome. Personally, I think it's awesome. Really cool tech. That being said, so what is our application architecture? What are we deploying? And how do we manage the deployment side of this thing? So yeah, you've probably seen diagrams like this, but yeah, we got a nice API gateway, and then we have effectively individual services. So we're a small team, but because we do so much stateless stuff, like we have some database bound work, but most of it is like taking images and slicing them and processing them and filtering them, or doing this to video, or doing like security analysis scans and all this stuff. So we get the kind of the benefit of just being able to use Go, concurrency, gRPC, and just byte slice, and just be able to effectively allow our pods to horizontally scale as more and more images and assets and PDFs and things come into the environment. So yeah, single API gateway. So from internally from other Bowl.com services.
Mommy picking me up,
We're gonna ride home. Almost there.
but I miss my mommy so much.
She is pretty, aw, but she is pretty cool. Shout out to Nicole's mommy on this one. Sweet. So yeah, you guys get auto scaling. These are stuff. This is stuff. We'll kind of blaze through that. So how does this impact our approach to sustainable innovation? Google does the heavy lifting. So again, we can focus on the abstractions of what Kubernetes provides us. Kubernetes unto itself maybe isn't necessarily simple, but I'm still kind of blown away by, for what it does, how simple it actually is. But that's a whole other talk unto itself. Services can be added and modified in isolation, of course, as long as our APIs are stable. So our API gateway is what the outside world at Bowl.com talks to, and we also have the other API that actual end customers talk to. One sec. But everything internally, we are able to modify kind of more freely because they're effectively encapsulated by our gateway. And then logical components can autoscale independently. So like right now, I'm talking and stuff, bytes are just getting thrown around the cloud. It's pretty cool. So that being said, microservices are complex. So how do we maintain this complexity? One thing right now, because we do have some stuff in Python from a data science perspective, but all of our Go stuff, we actually have in mono.
Daddy, Mommy was calling you.
No, I think someone else was calling him. Yeah, I know, not, yeah. So to simplify managing microservices and sharing code, all of our code is actually in a mono repo, but then we actually deploy these things as individual
Hey,
containers.
Daddy, I'm my code and your code.
Perfect, I think that's a great spot. So in that sense then, okay, so now we have microservices out there, observability, obviously a huge thing. We haven't adopted this framework called GoKit, but we've really adopted the principles behind it. And this is not necessarily a GoKit thing, but just I think Onion architecture is quite common in any runtime, and most things way beyond earlier than even my career started. But effectively, we have our business logic, and then we wrap metrics. So we decouple code that actually does the business logic, and then we ensure that that service is actually implementing a service that maybe just has Prometheus, which is then maybe implementing a service that just has our metrics, and it's kind of using middleware
Daddy,
to forward all of these
I'm
things
gonna
down.
charge to your telephone. Look.
Okay, do that.
But,
So this gives us-
it's already plugged.
Yeah, it's not plugged into the wall. Almost. Sorry, guys. I really do apologize for the drag. But cool. So observability. What does this give us? It gives us metrics. It gives us logging, and then tracing as well. It's kind of the last key ingredient to really being able to see what's happening. So you get logging, discrete events. Foobar just dropped a BazBuzz. Cool, I see that in Kibana, we can address it. Metrics, these things are all in Prometheus. So, oh wow, looks like we're drifting a little higher in our response times. And then tracing is like, why are we drifting a little higher in our response times? Oh, because that damn service that I wired up that I thought was gonna do something super cool is taking a long time to respond. So that's what tracing gives us on top of the kind of more traditional forms of metrics. This, of course, impacts our ability to sustainably innovate because now we see everything. When we roll out, we're able to roll out in incremental changes, and if stuff starts to have negative impact, we see it right away. And these things allow us to then deploy incrementally with confidence and then also roll back with confidence. And because we're not as database bound as maybe a lot of services that I have worked on in the past, we have a simpler time rolling back than I have had with other platforms I've worked on. So yeah, kind of get our service communication. Effectively, we use gRPC everywhere for synchronous internal communication. One quick thing about gRPC and Kubernetes, if you guys aren't already aware, gRPC is over HTTP2, which is super awesome, except that Kubernetes and most load balancers are HTTP1. So if you start talking HTTP2, what ends up happening is an HTTP1 load balancer, because it's a long persistent connection, will basically see it as one connection. So you start just going all fun with your new gRPC framework, and you have this beautiful cluster over here, and then instead of hitting all of the nodes, your load balancer just keeps forwarding all of the connections to one node, and this thing gets taken down, and you're like, what happened to the cloud, man? I thought this was supposed to be awesome. So how we solve this, again, because Bowl.com, we're one microservice with microservices in a large microservice landscape, we decided to go with client-side load balancing. And what's really cool is the Google team and the Kubernetes team and the gRPC team have released some pretty nice client-side load balancing stuff for gRPC in Go. And so the common option is to put like actually an HTTP2 load balancer, Istio, some kind of sidecar out there that can help route HTTP2 traffic. But with client-side load balancing, what was nice for us, or not necessarily network admins, we can now not have to introduce another like piece of something into our infrastructure. And so what this allows then there's kind of a caveat to this, but with Kubernetes it works really well. So effectively over DNS, your client-side load balancer will ask a DNS record for all of the IP addresses that
I
are
see
installed.
2 and 3.
You're right, I see 2 and 3. I see B and R too.
No.
Totally confusing. But really basically what this comes down to is your client can now ask where the IPs are, and then the client just round robins around. In the Kubernetes land though, this is not so great with DNS because pods may evict. Client still thinks B1 is there, and node dropped connections. So, but what's really cool is Kubernetes has a watch API. So we now, instead of using a DNS resolver, we actually use a really cool project called Kube Resolver. And what it does is it actually is getting updates from the Kubernetes API itself. So when pods are evicted, the client-side load balancer can actually get new information about IP addresses and then basically resume any no drop connections. And so no new infrastructure, and again, just effectively a simple hook into an existing API allowed us to now have all the goodies with HTTP2 and gRPC. Cool. Last piece is the parts. Well, gRPC itself, as you may know, does a lot of code gen for you in your runtime.
Stop, and then you need to come down to my home.
Oh wow, it's getting late for her. But that being said, one other thing, so we're now 5 engineers. There's a lot of code to be written, but there's a lot of boilerplate to be written. So, this guy, I think he's the most interesting man in the world. Taking, when I don't write code often, but when I do, it's incredibly interesting. And ideally, in Team Mirage, we're trying to get more and more to that. So generate more of the boilerplate, generate more of the boilerplate, as well as keep engineers interested. So for our JSON REST stuff, we are using Swagger CodeGen for all of our non-Go clients because it does a pretty good job. We're actually working internally with a team at Bowl.com that is that are super, super awesome with JVM, and they're working
Daddy,
using
now you need to stop up.
You're right, I should stop talking about CodeGen and get to the last slide. But so yeah, for all of our non-Go clients,
You
we use...
just need to stop that
Yes, come
thing.
here, come here. Just come here.
No.
Okay. Challenge. So Swagger CodeGen for non-Go clients, and then actually Go Swagger, which is such an awesome project for Go. So
Now
I
I'm
highly
going to
recommend
go
this
down.
if you're using Go and REST APIs. And then we of course have all of this in our CI/CD pipeline. So I love writing Java, I love writing Python, but right now I'm asked to write Go. So if I don't have to write Java clients, Python clients, Ruby, well we don't use Ruby, but definitely Python and Java a lot at Bolt, and other Go clients as well as Swift.
Daddy.
Now we just have this generated at the tail end of our pipeline.
You stop with a go-go.
Yeah, go. It's a cool language. Great, so yeah, this obviously impacts sustainable innovation because now we have 4 engineers who are not spending time writing clients. They're writing business valuable code. And then yeah, the last part of this is just, budget. What's so cool about cloud, and what's also not so cool about cloud is, it costs money. But what's nice about cloud is because you're charged effectively at the invocation or at the second or at the CPU utilization time, cost effectiveness now becomes a very addressable engineering problem.
You need to stop with that go-go.
You're right, I should probably write in Rust. But anyway.
No, you need to stop.
Cool, but so that being said, cost is obviously with fixed costs, there's a problem. But fixed costs for large engineering teams means okay, I have some budget, we just throw stuff on VMs and you guys
Daddy,
take care of it.
stop with that hanger.
Cool. I keep saying I'm almost done, so that I'm going to be actually almost done here. For us, it's
Go-go
awesome
needs
because
to
we can.
stop.
Come here, sweetie.
Nope.
Okay. So for us, what was really interesting. This is just an output from pprof, an amazing tool from Google for Go applications as well as C++. And we found that this is actually a Google, the gRPC stream client, costing us the most money right now. So we're running at Google. We're running at Google, and their code's costing us money. But actually, it was me using it wrong. So we found this out. Our actual memory utilization went way down, and we were able to allocate less resources, which means less expenses. And it's pretty interesting to see that in the cloud, where if writing more efficient code actually now has impact. Long time, probably prorated, and you can get into all the money stuff. But it's interesting to see how you can really affect cost in cloud. And then the last, this is a very epic topic. But the things we kind of highlighted, application resilience. So, is high availability something you need? If you can tolerate certain downtime, then do you want to pay for it? If you can't, then that's another cool thing about high availability. If one region falls down, you can if you have your stuff tricked out well enough, you can fall over to another. Retry mechanisms, being able to have we have a lot of services that use Google PubSub. And
Daddy, now you need to stop.
This actually. My last slide.
Go need to stop now.
Okay, so
Go,
application
now.
resilience,
Go,
which right now I'm totally failing my daughter. So in terms of resilience, so
go,
she's winning,
stop,
which is
go.
fun. But portability, security. I mean, these are really epic topics. I'm glossing over very, very important things with very, very epic
Oh no.
information to be unpacked in
Daddy,
each
if
one
you
of these
stop with
lines.
that go-go.
But at Bolt.com, of course, we have team autonomy, but these things are not necessarily all on our shoulders. We have other teams who also have specialized, figured some of these things out. And within Bolt, it's not just like, oh, I'm a team and you're a team, and we work together, but we hide code. It's open source within the closed source, and we get to benefit from each other's achievements in the cloud to make sure these things are in good shape. So failures happen. Let's basically take them as a given and design our CI/CD pipelines and our application code to be resilient towards them. So in summary, enabling autonomy. This whole concept, sustainable innovation, enabling autonomy, fundamentally, you need the tools to actually be autonomous. And this was a quick blast through those tools.
Daddy, if you
And sustainable innovation, and I'm Tom. So thank you guys for putting up with everything. But if there are any questions,
are you done, Daddy?
that's a good question. Well, I guess considering that question, unless there's anything super pressing, if there's something super pressing, me and Patrick are colleagues.
Okay.
I wasn't on the attendee list because he invited me so graciously kind of in the last minute, but there I am. Patrick's my go-to guy. Otherwise, if you're more interested about what we're doing at Bull.com, the really cool stuff we're doing with Go there, just it's stuff I can obviously talk about for a long time.
Oh, yeah.
It gets me kind of hyped. So anyway, thank you guys for your time and attention.
Oh, no.
And yeah, fine off. And, yeah.